Welcome to Kulicke and Soffa here at SMT Connect. I'm joined by Marco van Oosterhout. Nice to see you again, Marco.
Hey Trevor, nice to be back.
Okay. We've got a new machine behind us, which is really exciting. It's called the iFlex CX. Tell us a little bit about the machine, what the concept is, and some of its features.
Yeah. No, we were very proud on having this. This is the iFlex CX, which is basically the chip shooter part of the iFlex family. Mm-hmm. So having a machine which has an IPC rating of 75,000 components per hour on this footprint is quite good and remarkable.
Right.
And this being topped off with an iFlex T2 and iFlex H1 gives a very nice state-of-the-art, high-quality line solution.
Absolutely, yeah. So you built it on two H-beam gantries inside, which house, two pipette systems. How many pipettes are there on each side?
Yeah, so it has two H gantries indeed, and every side has two multi-pipette modules, which contains 10 pipettes each.
Okay.
So you have then 20 pipettes on each side.
Okay, so obviously using pipettes is a more accurate way of getting placement than using, say, a turret head or something like that. What sort of accuracy are you getting down to with the pipette system?
Yeah, with this system we are going down to 12 micron, which is a CPK 1.0 value.
Okay.
So that's a lot more accurate than the previous SMT machines that we had, and it comes close to our hybrid platform.
Right. Okay. So so it's designed really for high-speed flip chip placement and things like that, or what is it for?
Actually, it's for multi-purpose. It's also for the high-speed SIP applications, flip chips. It can do great on that, but also because of the amount of feeder positions. There are two trolleys of 66 positions each.
Right.
So that gives us a lot of feeder density for this small area. Right. So a couple of these together with a T2 is a good SMT, general purpose SMT solution, because you can pack a lot of combined products on it.
Absolutely, yeah. So that makes it really quite flexible. So this is actually the first one. This is if you like, a working prototype in some respects. What are the plans for actually launching it? You're going to do some beta testing?
Yeah, so indeed. So this is the prototype. We have done some internal alpha tests on this one. We go for the beta test later this year. We didn't have sketched the exact month, but it can be anything between August and October, November.
Right.
And then going into the industrialization phase, first machines out of the factory, that will be in calendar 23, aiming at May, June.
Okay, excellent. So May, June next year.
Yep.
Great. Are there any other specific features built into it? I mean, see, it's obviously built on linear motors and encoders to get the accuracy, the positional accuracy.
Yeah.
Are there any other features that are built in there?
Yeah, so we have learned a lot from our other concepts. Try to develop new high quality features in combination with what we already have. What this, for example, has is an active placement force control built into the placement head. Okay,
so what sort of force control can you get under? Is this for components that have got pin insertion and stuff like this?
No, it's more like having the touch on the board or on the substrate as gentle as possible and controlled as possible.
Okay.
And also nice thing of this one is that it has serialization of those modules, so we can also trace back, do the full traceability, and trace back what module has placed what component.
Okay.
And getting that out of the system via our KNext platform gives the smart factory flexibility and connections that is required.
Right. Okay.
And also a nice feature, because you asked for it, for that question, is that it contains so-called gang pick place. So the two pipette modules can place simultaneously the components.
Excellent, great. So any plans to obviously make it compliant with either SecsGen or CfX?
Yeah, for the CfX Hermes standardization, we are part of those committees. Yep. So it will have that built in.
Yeah.
SecsGen, the semicon standards, that's also of course needed for this one.
Yeah.
So yes, we'll have all those traceability connections done.
Good. Yeah, so this will make it the fastest flip chip placement system in the market.
It will make it a very fast, high accuracy component placement placer, suitable for flip chip, suitable for SIP components. Yes.
Yeah. Okay, great. Well, thank you for showing it to us today, Marco, and we wish you every success with the rollout of it, and I hope your beta trials go well.
Okay. Thank you, Trevor. Nice talking to you.
Thank you.
At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important.